Hello everyone. Consider the following power series expanded about zero. We are interested in taking derivatives of this to be able to solve the differential equation. So on the left side, if I simply write dy dx and I start differentiating the polynomial, the first term of course would be 0, and we'd be left with a1 plus 2a2x plus 3a3x squared and so on. The question is, what does that look like for the actual power series? Well, if you notice, first of all, it starts with a 1 and not a 0. And we've brought down the n from this term here, so it looks like this. So to do a quick check, when n is 1, I'm at a1. 1 times a1 times x to the 0. When n is 2, 2a2 x to the first. So then if I have a second derivative, which in this case would be just 2a2 and then 6a3x and so on, then that would look like, bring that down, n minus 1, an x to the n minus 2, starting this one at 2. And this would continue and so on and so on. So as we're solving a differential equation using power series, we're going to eventually have to substitute these quantities into the equation, but notice the starting points are different. So then that brings us to the question, if I wanted to start a power series somewhere else, how would I do that? For example, if I wanted to start this at 0 rather than 2, is that possible? Well, if I want this to be the first term, so I still want to have an x starting at 0. I would like this to therefore be just x to the nth, because then it would be 0. But then what about the coefficients? Well, let's see. Right now when n is 2, I have 2 times 1. I still need 2 times 1, but in order to do that, I'd need to make that n plus 2, n plus 1. And then the a term, starting at 2, let me move this over a bit, would have to be a n plus 2. So if we said, let's just look at the first few terms here. When n is 0, I have 2 times 1 times a2 x to the 0. When n is 1, 3 times 2, a3 x to the first, and so on. So one of the things we learn is we can shift the starting point at any time on a power series for convenience, because when we add them together, that's going to be an essential tool.